What if we told you there existed another universe and this is the afterlife you are living? Shocking, right? Let's take a look how it may have been possible. The Big Bounce is a hypothesized cosmological model for the origin of the known universe. It was originally suggested as a phase of the cyclic model or oscillatory universe interpretation of the Big Bang, where the first cosmological event was the result of the collapse of a previous universe. It receded from serious consideration in the early 1980s after inflation theory emerged as a solution to the horizon problem, which had arisen from advances in observations revealing the large-scale structure of the universe. The phrase, "Big Bounce," appeared in the scientific literature in 1987, when it was first used in the title of a pair of articles in German in Stern und Weltraum by Wolfgang Priester and Hans Joachim Blohm. The idea of existence of a Big Bounce in the very early universe has found a diverse support in works based on loop quantum gravity. The concept of the Big Bounce envisions the Big Bang as the beginning of a period of expansion that followed a period of contraction. In this view, one could talk of a big crunch followed by a big bang, or more simply, a big bounce. This suggests that we could be living at any point in an infinite sequence of universes, or conversely the current universe could be the very first iteration. However, if the condition of the interval phase, between bounces, considered the hypothesis of the primeval atom, is taken into full contingency, such enumeration may be meaningless because that condition could represent a singularity in time at each instance, if such perpetual return was absolute and indifferentiated. The main idea behind the quantum theory of a Big Bounce is that as density approaches infinity, the behavior of the quantum foam changes. All the so-called fundamental physical constants, including the speed of light in a vacuum, need not remain constant during a big crunch, especially in the time interval smaller than that in which measurement may never be possible. 1 unit of Planck time, roughly 10⁻43 seconds, spanning or bracketing the point of inflection. In 2012, a new theory of non-singular Big Bounce was successfully constructed within the frame of standard Einstein gravity. This theory combines the benefits of matter bounce and ekpyrotic cosmology. A few sources argue that distant supermassive black holes whose large size is hard to explain so soon after the Big Bang may be evidence for a Big Bounce, with these supermassive black holes being formed before the Big Bounce. We are still unclear and uncertain whether or not we had a universe that we existed, or is this the afterlife from the earlier universe we are living, or will there be another universe and will there be our afterlife? If you liked our video, don't forget to like, comment, share and subscribe to get great content regularly.